Hi everyone, in this video we are going to talk about rules of inference. In this first part we are going to study the theory, and then in a second part we are going to solve some exercises so you can understand how to apply this theory in practical examples. Proof in mathematics are valid arguments that establish the truth of mathematical statements. By an argument we mean a sequence of statements that end with a conclusion. By valid, we mean that the conclusion or final statement of the argument must follow from the truth of the preceding statements or premises of the argument. An argument is valid if and only if it is impossible for all the premises to be true and the conclusion to be false. In this case, we are talking about valid arguments in mathematics. So this is not the type of argument that you have in real life. Let's say, who is the best soccer player? It is not this type of argument. In mathematics, when we talk about valid arguments, we mean that the conclusion or final statement of the argument must follow from the truth of the preceding statements, which are also called premises of this whole argument. Once you state that the argument is valid, no one can express a different opinion and kind of say that the argument is not valid. So this is not the type of arguments that we are having in real life. One important technique that we use in mathematics is to deduce new statements from statements we already have. We are going to do that using rules of inference, and these rules can be also seen as templates for constructing valid arguments. They are the basic tools for establishing the truth of statements. So if we have a statement and we want to establish what is the truth of that statement, we have to use rules of inference. Consider the following argument involving two propositions. If you have a current password, then you can log onto the network. You have a current password, therefore you can log onto the network. As you see here, we are having two propositions as premises. This is the premise of our argument and this is the conclusion. You always will see the conclusion after the therefore, and we will see how can we write that with mathematical symbols. So what we want to do with this argument? What we want is to determine whether the conclusion you can log onto the network must be true when the premises are both true. So that's what we basically want to establish. If we can establish that the conclusion is true, whether the premises are true, then we just proved that the argument is valid. So let's see the definition. An argument in propositional logic, which is the topic we are studying, is a sequence of propositions. All but the final proposition in the argument are called premises, and the final proposition is called the conclusion. An argument is valid if the truth of all its premises implies that the conclusion is true. So this is what we want to prove. Okay, we want to prove that the argument is valid, and we are going to do so by proving that if all the premises are true, then it will imply that the conclusion is also true. From the definition that we saw before, we can also see that the argument from premises P1, P2, and Pn and conclusion Q is valid when P1 and P2 and Pn implies Q is a tautology. As you must remember, a tautology is a proposition that is always true. So for this proposition be a tautology, if the left side of the conditional is true, then Q must be true. So the key to showing that an argument in propositional logic is valid is to show that the argument form is valid. So now let's see what is the argument form of an argument. So let's say now we are going to use propositional variables to represent our argument. So let's use P to represent you have a current password, and Q to represent you can log onto the network. Then the argument will have this form. P implies Q, or if you have a current password, you can log onto the network. P, which is you have a current password, therefore Q. So we use this line to separate the premises from the conclusion, and this symbol is read as therefore. Okay, so this is the way that we state or we describe an argument in mathematics. Now the question is this a valid argument? So remember that for we to prove that the argument is valid, what we need to prove is if the premises are true, then the conclusion will be true. Okay? So let's see how can we do that. This is what we are trying to prove, that this form is a valid form. Is this a valid argument? Remember, we have to prove if the premises are true, the conclusion is also true. But we can also do it in another way. We can also prove that all the premises implying the conclusion is a tautology. Okay? So P implies Q is the first premise and P is the second premise. If the conjunction of the two of them implies the conclusion is a tautology, then we just prove that it is a valid argument. So how do we prove if this is a tautology? One way is to create a truth table, and another way is to modify the proposition using propositional equivalences until we find that the final result will always be true. If you remember the video from truth values, I mentioned that when we have 2 or 3 propositional variables, it is always a good choice to use a truth table because it is more simple. So let's see the truth table for this compound proposition. When you create a truth table, I'm not going to explain here how to create it because you should already know how to do it. If you still don't know how to do it, I will leave a link below to the video that shows you how to create truth tables. As you can see in the last column, no matter what are the values of P and Q, the truth value of the compound proposition is always true. This means that this compound proposition is a tautology. Therefore, we just proved that this argument is valid. So, do we have to do this all the time? Not really, because there are some forms that are already proved and then we can use them. So the previous argument is valid because its form is valid. So it doesn't matter what propositions we use to replace P and Q. If P implies Q and P are both true, then Q must also be true. So we don't have to do what we did in the previous example all the time to prove that the form of the argument is valid. So if you see here, this is the same example we used, and this is called Modus Ponens. So every time you see in an exercise or in a proof that you are trying to create this form, you can conclude that the form is valid because of Modus Ponens. So the same way, you have more rules of inference that are already proved and you don't have to prove it. But if you want to prove them, you can create a truth table for the tautology, or you can develop a series of propositional equivalence on the tautology to prove that the value will always be true. So these are the most useful rules of inference: Modus Ponens, Modus Tollens, Hypothetical Syllogism. When you have these premises, you can always state this conclusion. If you have these premises, you can state this conclusion. You just have to justify them by using the name of the specific rule of inference you are using. These Other rules of inference: disjunctive syllogism, addition, simplification, conjunction, and resolution. You can use any of them without proving them. You just need to mention the name of the rule you are using. So as a summary, we saw what is an argument form, and when arguments are valid. Remember, arguments are valid, which is the most important thing you need to have as a takeaway from this video. Arguments are valid if its forms is valid. And an argument form is valid if, whenever all the premises are true, the conclusion will be also true. If you learned something with this video, hit the like button. Thank you very much for watching. See you on the next video.